Hello everyone. Today we are going to talk about a very special topic of chemistry which is called concept of mole. So before we jump into this mole term, let me introduce to you some basic numbers such as, let me write down a dozen, 1,000, 1,000,000,000. So can you write it down? What are the values? We know a dozen banana. That means 12 bananas. 1,000. If we say 1,000 rupees, so what is the number? It is 10 to the power 3, right? Similarly, 1 billion, it's a very big number. What is 1 billion? It is 10 to the power 9. So these are some numbers which we can write down in terms of some specific words. Similarly, mole is a specific word which implies some numbers. Let me show you what is that mysterious number. 1 mole. It is a very mysterious number. It gives approximately 6.022 into 10 to the power 23. A big value. That means 1 mole is a big number, right? It has a real value which we can say 6.02214,076 into 10 to the power 23. This is the actual number, but approximately we use the short value. And this number is also called Avogadro's constant or Avogadro number. Scientist Avogadro introduced this concept or number. That's why it's called stop. Now, where to use this number? This is such a big number. So do we really need to use this number? In chemistry, it is really useful. Let me show you where do we need this number. Okay, so let me talk about hydrogen atom. This is the very first element in the periodic table. So, what is hydrogen atom formula? Hydrogen, 1 proton, and mass number is also 1. So let me zoom into this hydrogen atom. So inside a atom there is a nucleus and outside some electrons are there. For hydrogen, inside a nucleus only 1 proton, let's say this one is a proton, and outside 1 electron is there and nothing else. So if we want to measure the weight, how much weight of this atom, only single atom, what will be the weight? It will be the weight of 1 proton and weight of 1 electron, nothing else, because there is nothing except these two. And when we measure the weight, what we concluded that weight of the electron is very, very small, almost zero, negligible. That's why the weight of the proton is considered which we are going to measure. So now, but look at this, that for an atom, a very tiny particle and another very tiny particle. So weight of them will be very tiny. So what is the weight? For now, we cannot calculate directly. It is very difficult, right? Very small, one single atom in a weighing machine. How to measure it? It is difficult. That's why scientists came up with a clever trick. What is that? We talked about this Avogadro number, right? This is a very big number. So if we take a lot of hydrogen atoms, let's consider one hydrogen atom, two hydrogen atom, three hydrogen atom, four hydrogen atom, up to a lot of hydrogen atoms. How many hydrogen atoms are there? Let's take it up to 6.022 into 10 to the power 23 times. Means a lots of hydrogen atom. So now, if we want to measure it, how much weight it is? Let's take a beaker and put all the hydrogen atoms inside it. So if we want to measure the weight of this hydrogen atom, the weight, you will be surprised, it will give nothing but 1 gram. So you can measure 1 gram, 1 gram is a weight. So now what we have learned here, that a single hydrogen atom is very less weight because it's a very tiny atom. But when we take a lots of hydrogen atoms all together, it is giving a very good value. Up to Avogadro number, it's leading to 1 gram. So now, what's the conclusion of this? Now the conclusion, 1 gram of hydrogen atoms equal to 6.022 into 10 to the power 23 times hydrogen atoms. When we took this many hydrogen atoms, we got a very good number, 1 gram. So this is our very fast and very important conclusion in mole concept. Where to use this value? So we are talking about hydrogen atoms, right? So if we want to measure, let's say, carbon atom. For hydrogen atom, it has 1 proton plus 1 electron. For carbon atom, for 12C, so if we talk about 6, 12, that means 6 proton plus 6 neutron. For carbon atom, there is neutron, but for hydrogen atom, there is no neutron, plus 6 electrons. Now, when we are taking 1 proton, because weight of the electron is very negligible, weight of the electrons are very negligible. So if we take 1 proton, which is nothing but hydrogen atom, so if we take this proton or this hydrogen atom up to Avogadro number, we are getting 1 gram. That means 1 proton up to Avogadro number is 1 gram. But here 6 protons are there and 6 neutrons are also there. So now let's think that what will be the weight of 6 proton up to Avogadro number. 6 proton up to Avogadro number will be 6 gram, right? So 6 proton up to Avogadro number is 6 gram. What about 6 neutrons? So actually neutrons and protons are almost similar in terms of weight. So 6 neutrons up to Avogadro number will also give 6 gram. So for 1 carbon atom, there is 6 proton, 6 neutron. But for 1 mole carbon atom. For 1 mole carbon atom, there is 1 mole into 6 protons and 1 mole into 6 neutrons. 6 neutrons, let's make it this 6 neutrons, right? Now for 1 mole carbon atom, 1 mole protons into 6, or 1 mole into 6 protons and 1 mole into 6 neutrons are there. But we already know that 6 protons up to 1 mole is giving 6 gram, and 6 neutrons up to 1 mole is giving 6 gram. That means it is gonna give 6 gram, and this is also going to give 6 gram. So for 1 mole carbon, total for 6 protons up to 1 mole is giving 6 gram, and 6 neutrons up to 1 mole giving 6 gram. For total it's giving 12 gram. The conclusion of this is weight of 1 mole carbon atom give 12 gram. This is a fundamental situation, same as this. For hydrogen atom, as there is only 1 proton, it is giving 1 gram. But for carbon, there is 6 proton and 6 neutrons, which combine giving 12 gram. So we can make another conclusion, that is, if there is m number of proton plus neutron, here this is the mass number 12 for carbon. So if there is n number of proton plus neutron in atom, then 1 mole of that equal to m gram. This is called mass number, and in terms of weight, this is molar mass. Why? Because we took 1 mole of a atom which has m number of proton plus neutron. For carbon, 1 mole of carbon has 12 proton and neutron, that is giving 12 gram. Similarly, let's say oxygen has 16 proton plus neutron, 8 plus 8. So that's why 1 mole oxygen equal to 16 gram oxygen. 1 mole oxygen equal to 16 gram oxygen. So this is very useful in the physical chemistry and organic chemistry calculation and understanding. So we are back to one question of mole concept. Here the question is, how many oxygen atoms are there in 32 kg oxygen gas? So look at the question carefully. Here I have asked about oxygen atoms, and in the question it is given oxygen gas. So what's the difference? Difference is, oxygen gas we already know that it is O2. That means one oxygen gas contain 2 oxygen atoms. So now keep this information in mind. Let's talk about oxygen atom first. Oxygen atom has 16 molecular mass. That means 1 mole oxygen atom has 16 gram oxygen. That is the previous information we have learned. Now think about that 1 mole means that Avogadro number of oxygen atoms giving 16 gram. So let's think about what will happen if we double this amount, means let's take 1 mole of 2 times atoms. Basically, we are taking 2 moles, but we are writing 1 moles and we are talking about 2 times oxygen atom. So, if we want to visualize it in the picture, first we took oxygen atoms, let's say up to 1 mole. Now what we are doing, we are adding 1 mole more. Okay. Let's say oxygen in a pair. That's why 2 times of oxygen atom, like taking in a pair. So every oxygen atom is coming with another oxygen atom in a pair. So up to 1 mole. Here look at what happened. That first time here has 1 mole, means 1, 2, 3 up to Avogadro number. Here what happened? We added 1 mole oxygen atom more. We added 1 mole more oxygen atom, then it should be 2 mole. But what we did, we just put 2 atoms together to make a capsule. So then it ultimately giving 1 mole, because 1 mole is a number. So 1 moles paired with another mole is giving basically 1 mole. So this pair we can think of O2, because 2 oxygen atoms are combined in a pair. This is O2 molecule. This is oxygen atoms. This is O2 molecule. So these are 2 different things. Like double, when we double it, number count is same, but the atoms are getting doubled. That is the visualization of this concept. Now 1 mole of 2 times of oxygen atom, means we double it, is giving 32 gram. Obviously, because or we can also say that 2 mole oxygen atom can give 32 gram, 1 mole gives 16 gram, 2 mole gives 32 gram. But instead of doing that, we did a clever trick, that 1 mole, but oxygen atom we doubled it, like a pair. So amount is 1 mole, because mole is a number. So each capsule is up to 1 mole. Now think about these 2 times. We can write 1 mole, 2 times of oxygen atom is nothing but O2 gas or O2 molecule. That O2 molecule gives 32 gram. Understood? 1 mole oxygen gas gives 32 gram oxygen. 1 mole oxygen atom gives 16 gram. Similarly, 1 mole oxygen gas gives 32 gram oxygen. Why 32 gram? Because molecular weight of oxygen gas is nothing but 32. Molecular weight of oxygen double bond, here 16, here also 16, 8. So they are combined. So 16 plus 16 gives 32. That's why it is 32 grams. So if we keep this information in our mind, that 1 mole oxygen gas is 32 gram of oxygen gas, then we can think about what about 32 kg oxygen gas. So 32 gram O2 gas is oxygen gas, means 1 mole. Here same thing, just written reverse way. So now 32 kg. So when we are talking about 32 kg, that means we multiply both sides in 1000 times. Down to kg. 32 gram is 1 mole. What about 32 kg? 32 kg O2 gas. We can use unitary method as well. 32 kg O2 gas, 32 kg into 1 mole divided by this 32 gram. which will lead to 32 into 10 to the power 3 gram into 1 mole divided by 32 gram. So 32 is gonna cancel out. Gram gonna cancel out. We'll give 10 to the power 3 mole. That means 10 to the mole is a number, right? 10 to the power 3 mole is nothing but 10 to the power 3 into 6.022 into 10 to the power 23 times equal to 6.022 into 10 to the power 26. This many times. That means 32 kg oxygen gas has this many what? Oxygen gas. This many oxygen gas. Remember, here is an important thing. This many oxygen gas. Because we are talking about how many oxygen gas was there? 1 mole in 32 gram. For 32 kg, obviously it is this many or 10 to the power 3 mole. So now I have asked in the question how many oxygen atoms. So each oxygen gas has 2 oxygen atoms. So 32 kg oxygen gas, therefore 32 kg O2 gas equal to 2 into 6.022 into 10 to the power 26 times oxygen atoms, or these many oxygen atoms, because each oxygen gas has 2 oxygen atoms. That's why it is doubled. So this question is the basic concept of mole number, which will help you to understand this kind of conversion of weight to mole number or mole number to weight. So that's the summary of this chapter for now. So this mole concept will help you to understand many physical chemistry calculations, organic chemistry calculations, as well as inorganic chemistry calculation. Wherever there is a mathematical calculations, mole concept will be there. So I think that's it for today. Thank you, appreciate it.